Hi, our group name is Team Mega 969. And for KNP3053 manufacturing system, our product is car tires. My name is Muhammad Aiman Daniel bin Adam, and my group members are Khwarizmi Kushairi bin Mahran and Muhammad Irfan bin Ahmad Fauzi.
Okay, let's talk about agenda. We have 12 agenda. First, introduction, objectives, problem statement, manufacturing process and assembly, manufacturing process, production machine, human resource, material transportation, storage, identification, layout, and references. For the introduction, car tires are very important for vehicle safety because they give traction, stability, and support while driving. To make a tire, several steps are involved such as mixing, introduction, tire building, curing, and final inspection. Each step must be done accurately to produce a strong and safe tires. Many tire factories still use a lot of manual labor, which can slow down production and cause inconsistent quality. To solve this, semi-automation is used. Semi-automation improves product consistency, speed up the process, and reduce workers' physical effort. It allows human and machine to work together more efficiently, leading to better performance and safer working conditions. There are several problems in the current tire manufacturing process. First, there is too much manual handling, which causes inconsistent quality. Second, material movement is slow, especially between mixing, extraction, and tire building. Workers also face fatigue from heavy and repetitive tasks, which can lead to errors or injuries. Because of this issue, the production cycle time is not stable, and it is difficult to meet the higher market demand for 2026. Finally, limited automation makes it hard to scale up production. Our project aims to introduce a semi-automated system with several objectives. The first objective is to improve product consistency by automating important processes. Next, we want to increase production efficiency by reducing manual bottlenecks. We also aim to improve worker safety by reducing heavy lifting. Another goal is to optimize material flow between workout sessions using conveyors or automated system. Lastly, we want to create a balanced system where machine handle repetitive tasks and worker focus on monitoring and quality control.
To produce a tire, it involves a few manufacturing process. The first one is compounding. This is where all the raw material is mixed. Raw material placed in high intensity internal mixer. The mixer shear and blends the material using strong counter-rotating rotors inside a seal chamber. The raw material that have been mixed went through a process that called component preparation. The component preparation stage is where the parts are actually made. This process involves three distinct operations, which is extrusion, calendering, and bead winding. The extrusion process uses mixed rubber to create the main functional components that are entirely rubber. The calendering process combines the rubber compound with the reinforcement material like fabric and steel to create the structural layers. The bead process is a process of coating steel wires with rubber multiple times and attaching filler rubber. And then all the components that have been prepared are being assembled by layers. The inner liner is the first part installed on the tire building machine. The body plies and belts, which are frequently composed of steel and polyester, come next. Plies and belts maintain the tire's flexibility while giving it strength. The belts are cut to the exact size and angle. Two hooks of bronze-coated steel wire are inserted into the sidewall of the tires. The components are firmly pressed together and created the green tire, or what we call the uncured tire. Is curing and finishing. The uncured tire, green tire, is put inside a mold and inflated to press it against the mold. The tire was directly heated at high heat and pressure. This heat permanently transformed the rubber from a soft plastic state to a durable elastic state. Every tire is then inspected, and sample tire are randomly taken from the line and tested. The manufacturing process to produce a tire can be classified into two. The first one is processing operation. This is where raw material mixing, component preparation, tire building assembly, and curing take place. Second one is inspection operation. This is basically the operation after the tire is processed. This process involves two process, which is visual inspection and X-ray inspection. Then we go to the production machine. The first machine is the Banbury Mixer Ferrell 440. This is where the compounding process takes place. It is designed for high volume industrial rubber compounded with a mixing capacity of 370 liters. It is generally suitable for car tire production. And then the next machine is the Syndex single screw extruder. This is where the extrusion process in the component preparation take place. The material entering the extruder has already undergone intensive mixing and dispersion in the Banbury mixer. The extruder's primary job is not to compound, but to convey heat and shape the already mixed compound. That machinery's three-roll type calender are a popular and useful option in the calendering process. The machine is made of steel castron alloy, whose work surface has high hardness, so it is wear resistant and durable. The next machine is the Batel SWS 6000 single wire bead winding system used for bead process. It can produce up until 6 single wire beads per machine cycle. It produces highly uniform single wire hexagonal or square section beads, which are required for precise seating and structural intrinsically in PCR tires. PMI makes radial passenger tire building machine. This is where the assembling process takes place. This is basically where the tire is assembled layers by layers. The main purpose of TBM is to assemble component with millimeter level precision, since a slight error in alignment may have result in a worse performance and safety of the tire. The next machine is the VMI H200T tire curing press used for curing process. It comes with a 52-inch maximum mold diameter and a bit diameter range from 50 to 23 inches. It also has the fastest cycle time in the industry. The CTX STM plus X-ray used for the X-ray inspection part. Tires are X-rayed vertically to minimize deformation. The machine is completely autonomous, meaning that no operator is needed to operate it while the machine is ongoing. It is perfect because it ensures that only structurally flawless tires advance to the next stage. The next machine is the Hoffman RGM E-Series tire uniformity machines. This is used for the visual inspection part. The RGME machine is built for automatic examination and is integrated into a production line. The RGME is the industry standard for ensuring the cured tire meets the tight ride quality specification demand.
For the human resource, currently workers face a lot of physical and mental strain due to manual lifting, cutting, and assembly. This causes fatigue, which increases the chance of human errors such as misalignment or inaccurate measurement. Some sessions require more manpower than others, causing an unbalanced workload. With semi-automation, heavy and repetitive tasks can be handled by machine. This reduces worker fatigue and allows employees to focus on supervision, inspection, and decision-making. Overall, this improves efficiency and work quality. In the current system, material transportation relies on trolleys, forklift, and manual handling. This causes slow and inconsistent material flow. There is also a risk of material damage and safety hazard due to crowded pathways and heavy items. By introducing automated transportation systems such as conveyors or AGVS, materials can flow smoothly between processes. This minimizes delays, reducing handling damage, and make the factory safer. Automated systems also allow supervisors to track material movement in real time and reduce bottlenecks.
Let's start with our part storage system. In traditional warehouses, floor stacking is common, but it takes up immense space and risks damaging the products. Instead, we have integrated a fully automated storage and retrieval system, ASRS, featuring high bay racking. There are two main engineering advantages here, which is optimization. By utilizing vertical space, we drastically reduce the facility footprint and eliminate the safety risks associated with forklifts in narrow aisles. Next, the quality control. We use specialized cradle pellets that store ties vertically. This is crucial because it prevents flat spotting, which is a permanent deformation that happens when tires are stacked on top of each other. Furthermore, our warehouse management system strictly enforces FIFO, first in, first out, protocols based on the rubber's aging properties, ensuring no tire sits longer than its shelf life allows. Moving on to the next part, which is identification. How do we track millions of black round objects that looks identical? We utilize a hybrid identification system. While we still use standard codes for legal regulations, our primary internal tracker is RFID technology embedded directly into the tire sidewall. Why RFID? The speed. Unlike barcodes, RFID does not require a direct line of sight. We can scan an entire pallet of tires instantly as it passes through a gantry, speeding up inventory checks by roughly 400%. Next, the traceability. This tag links every single tire back to its specific raw material batch and curing parameter. If a quality issue arises later, we can trace it back to the exact minute it was cured and the specific rubber mix used. Finally, let's look at our plant layout strategy. We have adopted a product layout, our linear flow line. As you can see in the timeline, materials move in one unidirectional flow, from mixing to extrusion to assembly to curing and finally an inspection. We designed this layout with specific engineering constraint in mind, thermal zoning. Notice the assembly and curing are placed immediately adjacent to each other. This is critical. The green tire and cured tire is soft and deformable. By minimizing the travel distance here, we prevent shape distortion before it is vulcanized. The automated handover. We've eliminated flow buffers between curing and inspection. The direct conveyors ensures tires are inspected immediately while they are still warm, providing the most accurate uniformity data. This layout minimizes material handling space and material handling distance and prevents bottleneck, ensuring a lean manufacturing process. For our references, we use Google Scholar and Google as an engine for our research. And that is the end for our project of manufacturing system for our product